Yes, trust we all had a wonderful day. Trust our day was good. I can see Mohammed, I can see Akishe, I can see Sunday also too. I can see Sunday also too. Yeah, so I need to confirm if you can all hear me. Can just make use of the chat box so as to confirm if I can all hear me. Okay, that's fine. Okay, thank you so much, Isu, for that feedback. Okay, thank you so much. Akise, I hope I got the pronunciation right, not just pardon me. So we'll be looking at okay, thank you so much. Yeah. So in our class yesterday, I gave you a walkthrough on a background in data science. I told you about what data science is all about and the problem we try to solve in data science. So let me just my camera. So you think it's chat GPT or an AI that's communicating with you, the human being actually. Yeah, so we we look at different problem we can solve making use of data science. These are we have supervised learning, we have the unsupervised learning, and we have the reinforcement learning. And we said our supervised learning is basically divided into two parts. That is the classification and the regression part. And we also look at the unsupervised learning. And likewise, we look at the reinforcement learning. So these are the three scenarios whereby we basically work, we solve problem, making use of data and making use of scientific method. So this class, I'm going to give you a walkthrough of how we can solve one problem. So that problem is, let me share my screen so you can see. So you can see what we're trying to solve. Okay. I believe you can all see my screen right now. So we are trying to solve a particular problem. So this problem has to do is we are applying data science in an health organizations. So it's pretty straightforward. So looking at the contents, we said that in an hospital, medical treatment and surgeries can be categorized into inpatient and outpatient procedures. For patient, it's important to understand the difference between these two types of what cares because they impact the length of a patient's stay in a medical facility and the cost of a procedure. So what is an inpatient and what is an outpatient? So the difference between inpatient and outpatient care is how long a patient must remain in the facility where they have the procedure be done. That's like probably the operation or surgery. So in outpatient care require overnight hospitalization. Patients must stay at the medical facilities where their procedure was done, which is usually a hospital, for at least one night. During this time, they remain under supervision of a nurse or a what? Or a doctor. So we have patient receiving outpatient care do not need to spend the night in a hospital. They are free to leave the hospital once the procedure is over. In some exceptional cases, they need to wait while anesthesia will or make sure there are not any complication. As long as there are not any serious complications, patients do not have to spend the night being supervised. So we have a problem to solve. We have this hospital that working on building a model to determine if a particular customers, like if a particular patient, not customer, if a particular patient needs to actually stay in the hospital or live in the hospital based on some certain numeric factors, variables that are being collected. So we had to actually build a model for this. As if we are working as a data scientist in an hospital. So we have data being collected. We have data being collected. So these are the data. So hemoglobin, erythrocyte, leukocyte, thrombocyte, MBC, MCH, MCHC, MCV, age, and sex. And we have our source. So this source, one means that the patient have to wait. Y0 means that the patient have to go. So that's what it basically means. Looking at this problem right now, we have a supervised learning and we have a classification problem. So if you have this kind of problem now, you want to make use of the chart I showed you yesterday. So let's just go back to the chart. So after we identify that, okay, this is a supervised learning, is a classification problem. We want to make use of any of these algorithms. I will basically make use of all of these algorithms. But in today's class, I'll just focus on the first algorithm, how we can actually implement the first algorithm, that's logistic regression. And when you join our paid class, you can learn how to actually implement other actual algorithm in solving these tasks. So we are going to be making use of logistic regression in solving this particular task and check the accuracy. So once we're able to check our accuracy, then if we feel our accuracy is not good, that means logistic regression can't solve that particular problem. You want to move to naive Bayes. You want to move to KNN and decision tree support vector machine and forest, random forest also to see which of these algorithm give you the best accuracy in solving your problem. So that is basically what we do as data scientists. So we have our data being collected. So our data, these are the data that is being collected. Now we need to build a model on. So we call these our training data set. So these are our training data set. So with this data, once we're able to build our model, as you can see, everything I highlight here, they are basically our what independent variables, while our sources are what dependent variables. So once we're able to build our model, then we now need to test it on our test data set. This is now the data set they give us probably every day, depending on how big the organization, how big the hospital is actually is. So we can look at our test set here. We have roughly, I think, for me, 1,000 plus count of these, the count that we actually have 1,103 data that is being collected for that particular data. We need to check now. So our goal is to predict that, okay, with this data that you have, you need to check if this particular user need to be staying in the hospital or you need to be leaving the hospital for that day. So that's the basic thing we are actually requested to what to solve. So that's the basic thing we actually requested to solve. I don't know if that explanation I gave was able to give us an idea on what we are trying to solve. So you can just make use of the chat box so that I can confirm that before proceeding, or I'll give you another explanation on that, because it's very important as a data scientist to understand the problem we are trying to solve. Yes, okay, thank you so much. So because of our time, I'm going to be making use of a libraries. I'm going to make use of one of the tools that we use as a data scientist, and it's going to be the online versions. So I'm going to be making use of the online version. So because the online version, the only caveat that you have with the online version is that you must have a Google account. So and I think everyone here should have a Google account in solving this particular problem. So I'll just go to online. With further, we already seen our data. These are our training data sets and our test data set. If you could see in our training data set, we have something we call the source, but in our test data set, we don't have something called the source. So what we need to do is to build a model that will work with our with our training data set, then we use that model to predict our source. So that's what we are basically doing in this particular project. So proceeding from there, I'm going to just go to online, just go online. Okay. So we have a particular environment that we can use to solve our problem, pretty straightforward. And if you have your system close beside you, you can also follow. If you want to follow me along, you can just follow me along also too. Why? Let me just drop the data sets we'll be making use of. Yeah, this one. Yes. Mm, yeah, just a minute. Mm, sorry, just 1 second. Sorry about that. I just need to fix something up for us. Yeah. So let me just share the resources we'll be using. Okay. So we can have access to this. Hope we're excited about what we are trying to work on. Okay, you said this course is currently in use, so I need to close this. So I need to close this. Are we excited? It's just let's make use of chatbots before we start the project. You will basically answering most of all the questions, even though you are a newbie, it's something we are always familiar with. It's just our reasoning that we are just looking at into this class. Just our reasoning skills. It's going to be an interactive sections. So I really need our 100% attention because I'm going to be asking questions. Okay. Left. Okay, so let me share my. So for we to start this project now, we need to go to an environment called Google Colab. So just type Google Colab on your. So we have Google Colab. So we have Google Colab. So you can see this is my Google Colab. For you to have access to Google Colab, you need to have Google accounts. So I strongly believe so you can click on let's click on Google Colab itself. So let's click on Google Colab itself, but you have to be connected to the internet. So I want to click on a new book or document also too. Sure, I'll definitely share the Word document also. So let me just drop that also too. So I need to close it. Okay, let me save this. Save it. Save as documents. Let me see what's the difference. Seconds. Okay. So I'll need to close this out for you. so I can send it to you. Okay, that's the best. Documents. Now, where do I see this? Okay, as it's there. Okay, so I've sent the document also too. So I don't know why people are unjoined. So you can check the WhatsApp group so that you can mark the attendance for today also too while we proceed. Okay, so I need to open a new notebook. So once I go to Google Colab, then I get to this place. I open a new notebook. I'm creating a new project. So I open a new notebook. So it's coming up. So I'll open a new notebook. So this is the environment, you can see. So this is how it actually looks like. So we have all of these informations. So I need to upload my data. So I just come to this folder side. I come to this folder side. So I come to this folder side, then I click on this to push up my project, my data itself. So I open here. So I'll just import the test data, the training data set. So text so I just check for the training data sets. I think I found it below. Okay, this is um, it's opening, so it's going to ask you, just say okay. So it's been, I've saved it now. So I've uploaded it over to my environment. These are environment. So then I need to read it into the environment. Then I need to read it into the environment. There's a library we actually use in reading it into the environment. Before we can use that library, we need to call the library. We need to call it before we can actually use it. So we just say import. So we call it import pandas. Pandas are speedy. So we are saying import pandas, just like pandas is the name, but I'm saying that I'm going to rename it as speedy. So that's what it means as speedy. So click on this to run because I want to read pandas stand for panel data. So I'm reading an Excel file. As you can see, this is an Excel file. So I'm actually reading an Excel file. So I'm going to give it, I'm going to read that data in. I'll just save it with name called data. I'll just say name called base. I can just say patient data also too. Patient underscore. Let me just use data because I don't like the word patient. So data. So I need to read it in. So I need to read that data in. So I'll just call it that will be PD because I need that environment to use. So instead of calling pandas in full, you rename it as PD. That will be read. We have read underscore Excel. So I'm reading an Excel file and I open into brackets. So I read underscore Excel and in quotation, we have then the name of the file. So it has to be exactly the same way spelled here. So we have train underscore data dot xlsx. Then I want to read it. So if that is correct, you won't have an error. So that is actually correct. So the reading it is correct. So what you want to do is want to say, okay, we want to see if this reacts this data actually. So if you want to check your data, we have a function that will help us check our data, like will help us view our data. So we call it head. We call it head. So data dots. So we have data dots head into brackets. Then we can run it. So this gives us opportunity to view the first 5 information of our data. So this gives us the opportunity to view it. So you can see just like similar data set you can see on my Excel sheet. This is just like a fractional part of that, the first half of the information. So this is how we can read our data. So you can check the tail of the data also. That's the down part, the last 5 information of the data. So you say data dot tail into brackets. And we can run these also too. So we can see this is the last 5 information of the data that we can see also too. So we are pretty good with what we actually have. So we are pretty good with what we actually have. So what we want to do is just to check our data set. So we want to check the number of rows that we have and the number of columns. Even this is saying 3308. So we have a function that can check the number of rows that we have in our data, which is called the data.shape. So we have data.shape that is going to give us the number of rows that we have and number of columns. So we have 11 columns and we have this number of rows. So we have, you look at this place, we have 330 because in Python, the starting number starts from 0. With this 0 here now, you have 3309 that you have in this place. So from there now, we can have the columns name that we have. You can see the columns name. There are 11 in numbers. We can have a code that can give us the name of the columns also too. So yeah, so say data.columns. So we have data.columns. I think this is wrong. The spelling I gave is wrong. Columns. Data.columns. So this is what we can see. So this is just like giving us inspection to the data we actually have. So do we have any questions so far? Starting from where I actually begin, how we can read the data in, check the first 5 information of the data, and check the last 5 information of the data, check the shape of the data, the number of rows we have, and the number of columns we have. We check the columns of the data also too. So do we have any kind of question regarding that? Okay. Okay, perfect. Then thanks. So from yes, now we can now move to check if we have any form of duplicates in our data. So if we have any form of duplicates in our data, we need to check if you have any kind of missing data also too in our data, because this is just like a quick and a simple uh, building of our model, even though if we have to do the work in full-time basis, it's going to be taking much more time than we are doing. But this is just to introduce us to an aspect of using data to solve problems. So we really understand the problem we are trying to solve. Okay, thank you so much, Olatunji. So I'll just still turn off my video because it's affecting my system resources. So the next thing we want to do is to check for duplicates. Probably we have duplicates in our data. So that's the next thing we want to check if there's a form of duplicate in our data. So what is a duplicate? Duplicate is the sense that if we have a row that is similar to the other rows we actually have. So once we have that, then we can now say that, okay, we want to drop this duplicate. So we can now say that we want to drop this particular duplicate. So that's one thing that we need to check. So that is going to be one of the next steps we need to perform when you're doing your data cleaning. You need to check for duplicates in our data. So I'm going to just do that now. So far, we already save our data into the variable name called data. So far, we already saved that into what we call data. So we need to check for duplicates. So you say data dot, so so we have duplicates. So we have duplicated. Then we have duplicated. We have dot sum. So you can see, so we have 0. So we don't have any form of duplicate. So in our data, so this kind of function we use, data dot duplicated or sum is what we use. to check. So there's no any form of duplicate in our data. So we don't have any form of duplicate in our data. So we can just proceed. From there, we need to check if there's a particular column in our data that is actually missing also too. So we need to check if we have any data set, any column in our data that is actually also missing us. So the data dot is null, two brackets, then we say dot sum, then we run this. So that means we have 0 or true. So we don't have any form of missing data. So all our data is basically what? Complete. So we don't have any form of what? Missing data in our what? In our data set. So this is what this particular aspect actually means, that we don't have any form of what? Missing data. So if you have some form of missing data, you see some value attached to it, then in case you have a duplicate, the thing you want to do is to drop that particular duplicate. And if you have a missing data also too, the thing you want to do is you may want to manipulate. You may want to manipulate. So the process of doing those kind of manipulations are things we actually teach our students in our full classes. So thank God we didn't have any form of issue with missing data. So after we've done that, then you can now say you want to move into the aspect, probably you want to visualize. So these are aspects you can also move to. Probably you want to check the population of the sex. How many male do we have? How many female do we have? So we just do something called data selection. So I'm selecting the column for sex. So I'm selecting the sex column. So how do we select the sex column? You just say data, and we have a square bracket, then quotation, we have capital EX, which is the sex. So then we say dot values underscore count. Then we run this. So this gives us the population of the female, and this gives us the population of the male in our data set. So we can do the same thing, just copy the same code to get the count of those that are patient, that are impatient, out of patient, and impatient. So that is the name of that particular column is our source. So just replace this with our source. And we can run this. So the number of out of patients, I think those ones that are going home and those ones that are staying within the hospital. So outpatient and inpatient is this, and the outpatient is this, which is quite okay. Which is quite okay. So we good with that particular check that we did. In case you want to do some visualization, so we have some kind of visualization that we can also carry out to help us with our data set. So we have some visualization we can also carry out. So let me use a sample of one visualization we can make use of. So we can make use of okay, so let's take a sample of a visualization that I can actually make use of. So let me see from my previous code. So if I'm going to the area of visualization, I think this should work very, very fine then. So I can take for the sex, I can copy this and paste this, dot plot. Then what am I plotting? The kind of plot I want is kind is bar. So we have bar charts. So I want to plot a bar chart. My Y, that means I'm assigning my Y. So it's showing me probably, okay. I need to put this in quotation. So that's why we have this. So we have a bar chart. And my Y could be so that will be the value column. So I just say value underscore columns. So value underscore columns. Then we want to call the title also too. The title of the graph, that could be you just say frequency distribution of sex. I think sex, yeah. 6, and we can run this. So you can see the way the graph comes up. So we have this. So we have this as the graph. So just like we're representing these values. So these are things we train our students on in our full classes of how to perform more advanced and sophisticated, because this is just a simple text to build a model. So this class is basically focused on us learning how to build a what? A model. So we're done with this. One issue we actually have right now is that when building our model, so when we are trying to build our model, all our variables have to be numerical. So this is numerical, I'm okay with this. This is numerical, I'm okay with this. This is numerical, I'm okay with this. This is numerical, I'm also okay with this. This is numerical, I'm also okay with this. This is numerical, I'm also okay with this. And this is numerical, I'm also okay with this. So the only one that is not actually numerical here is only this sex. So this sex is not actually what? Numerical. So the sex is not actually numerical, then I will have to be very, very concerned about that. Because once you try to build your model and you are making use of non-numerical data set, you are going to have an error. So you are going to be having an error. So what we need to do is we should ensure that we convert this sex by saying either male should be 1 and female should be what? 0. So you can use our male to be 1 and we can use our female to be 0. And one of the beautiful aspects of it is that we can implement these things making use of so we can implement this thing making use of the already made libraries that we have in Python. So we have some libraries that can actually help us to solve this in Python. So that's one of the beautiful aspects of this. So let's see how we can actually solve this by converting our categorical variables into number sets. So we have a particular libraries that can help us in in um in converting this into numerical words sets. So we have we have different aspects, different ways we can actually solve this. But I'm just going to be making use of the one of the simplest ways we can actually solve this into we call this label encoding. So we want to so that we are using a what we call label words encoding. So we have some that is also um auth encoding also too. One auth encoding also too can also be used to solve this particular problem. So you can use a one auth encoding also too to solve this particular problem. So the one I'm just going to be making use of is let's make use of the one auth encoding. So let's make use of the one auth encoding. Then you can see how this actually works. So you can see how this actually works. Okay, so just 1 second. So I want to say from sklearn, then so we have a library called sklearn. So as a data scientist, you'll be making use of sklearn a whole lot of time while you are working on a project. So we want to say S from sklearn. So from sklearn, sklearn dot preprocessing. Yeah, so pre-processing imports. Excellent pre-processing. Excellent pre-processing. Okay, so this imports label encoder. So once you import label encoder, and we can run this. So if We're good with that. So this is going to help us convert. So we can see it's as if we are converting this M to 0. So system determine how it's going to convert it. Our only is just for us to pass the code into the what? The system. So I need to initialize this. Okay, I'm making use of a particular stuff. So I can say encoder. You can say encoder equals to label. So I need to initialize this label encoder. So I initialize this and run this. So I've actually initialized that particular variables. So what I want to do is to apply it to my sex. So I want to apply it to my sex. So I need to select it, say data. I'll select sex that is into quotation. So we have sex equals to, then I need to apply that encoder. Encoder dot. So we have a function fit transform, fit underscore transform. So I want to transform that particular into what? So I just say, what am I transforming? That is data, square bracket, selection, sex. So I can run this. So I'll run this and I can check if my action is being settled. So I can check that if my action is being resolved by checking the head of the data again. So it's a data dot head, two brackets. So you can see now, so we've convert our sex from male to female to 0 to 1. So I know, I think male is 0 and female is 1. So I'm good with this. I've done this part, which is part of my modeling by ensuring that all my variables are numerical. So the next thing I want to do is to classify my data into the X and Y. That is, identify those that are the dependent variables and those that are the independent variables. So I can say my X will be my independent variable. So X equals to, I can have data into square brackets. So I'm selecting multiple columns. I already have our column names up here. So I can just copy all these column names except source, except our source, which is our dependent variables. So we have this, and I have this. This is my X, and I can have my Y. So my Y equals to data square brackets, and we have source. So we have source. Capital is the source. I can run this. So that is our X is this. This is our independent variables. And our Y is this. This is our dependent variables. So this is what we have after we split our data into this. So there's something we basically used to do also too, because this is our training data set. And these are training, just a second. So we've actually identified our dependent and independent variables. There's a particular process we actually used to carry out in building our model. So one of the model we're actually building is the logistic regression model. So and we get that model from the sklearn. So these are sklearn to actually get our model. So I just create a new. So from sklearn, if I type sklearn from sklearn, so you can sklearn, then we have logistic. So we have some documentation online that can actually help us. It's coming up. So this is a documentation that can actually help us in building that particular model. Pretty straightforward. So we have, so I can't tell, so just like I said yesterday, but I can't go much into how the logistic regression actually work. But we just go into how we can actually implement the logistic what regression. So we just see how we can actually implement the logistic regression. So we can see how we can actually implement the logistical regression. So I'm looking for the code aspect. Okay, so I think I stopped sharing. Oh, did I jump to this side? Sharing and sharing. Okay, so let's go back. So I'm looking for, okay, so this is, but before we do this, we need to do something called train test splits. So we need to carry out a process called train test split. That means we are going to, this is an example, and we'll implement this example while we are performing these actions. So I need to carry out a particular step called train test splits. So I'm going to show you how it actually works. So the same things from sklearn also too. So the sklearn is a very important aspect. It's a very important tools. So you can see, so train test splits. So we are going to divide our data sets. These are data sets that we're actually working with. We are going to be dividing it into two parts, the train part and the test part. So build a model with the train part and use to check our test part to actually check the accuracy of our model. So okay. So this is the name here. I'm just going to copy this. This is like a standard. I'll copy this and paste it here. I'll run this. So once I run that, then I want to copy this part, which is necessary for my project. I copy this part. Then we have our X, right? Small X. So we have our Y also too. And we said the test size. So I'm saying that I'm just going to use 0.3. 30% of this data should go to our test site and 70% should be my training part. So I'm going to build my model on the 70% of the data, or let me just use 20%. So 80% of the data I'll be using to build my model and 20% to check the accuracy of the work of the model. And we have a random state. The random state is to ensure that both of us have the same values when we divide. So, division is randomly so that we have the same random selection. That is why we have the random state. So I'm just going to run this. So I'm running this. So we have our X and Y already established, which is now our S train, our Y train, and we have our S stress down. So let me just call this out so you can see it. So our X train. So these are S train. Just like a sample, we are S train. Just pick a fractional part of it and have our X test. So now in our X test, you are not going to have a source. So you can see that the source is actually missing our X test. But if we look at our Y train, we have our Y. So Control Z, C, Control V. Under our Y, you can see this is our source. Under our Y test, which we also have, which belong actually to the what? To this S test. So we are going to be building our model with our X train and our Y train. Then these are X tests, we test it. Once our X test, we test, then we'll compare the results with our Y test to see what we actually are, if our model is good or not. If it's not good, then we need to use another word, algorithm. I think I need to build this for you here. So we can come here and now build our model using our logistic regression. So I need to call logistic regression. So say from sklearn, that's what model, then we have what's the logistic what regression. So that's the model we are actually building. So we can load that, then we can call this out. So I can call this classification out. window. I need to initialize this. I don't need to call it out straight. Need to be initialized first. So what this guy is doing, they're not doing the right thing. So this is not correct. So I can just say our model equals to logistic regression into brackets and run this. So I initialize it just like the way I initialize this guy up here. So you need to initialize it. So once we initialize it, then we need to fix it. Then we need to fix the data set. So that is the next thing we need to do. We need to fit our model. So how do we fit our model? We just call it and say model, which is the name of the model, model dot fit or fit, which is our S train and Y train. So train it using our S train and use our Y train. S train and we have our Y train. We have our S train and we have our Y train. So it shows that okay, this is a warning, this is not an error, this is just like a warning, but our model has been fixed. So we already built our model. So we already built our model. So that is one thing we've done. We've been able to build our model. Just as simple as ABC like that. So once you have our model, then you want to predict. So that is the next thing we want to do. So you can say prediction. Prediction equals to the model, which is this, the model we built, which is the model dot predict. So we have predict for our X test. So we use our X test to see if we have the same result as our Y test. So we use our X test, paste it here. So we have our prediction ready. So we have our prediction ready. So we can check our prediction. So this is the result of our prediction. So these are the results of our prediction, as you can see. So we need to check the value of our if our prediction actually tallies with some may tallies and some may not actually tallies, but we need to check all of this. So to do that, we need to say we can put it as okay. So that is our Y test. So we can have accuracy. We want to check the accuracy. Just say validates equals to PD the data frame. Then we have predictions. We can have prediction. This is can have prediction. And we can have okay, and have our Y test. We have our Y test. So let's see if this works. So we can call our validates. So you can see both of them. So this is 0, 0, this is 1. So the real data set produce 0 and this produces 0, which is correct. Our model, this is the result of our model. This produces 1 and this is 1. But this one is a miss. This one was not correct. This is not correct. This is not correct. So some of them are correct, while some of them are not correct. But you need to check this accuracy in a more better way by using a particular function called confusion matrix. So we have our confusion matrix. So we can say, can come here and just go to from S confusion matrix, from sklearn. So everything you can see, everything I'm picking everything from sklearn. So we have confusion matrix from sklearn. So I'll just check and scroll. I'll just check and scroll. So we can have this on this, we can import this, and we can run this. Then I think what aspect do we need to do? So we need to call this, just call this. So we have, but now we are having our own to be these guys. So we have them to be these guys. So just copy them and just run it. So this, so you can see the confusion matrix. So you may not be able to understand this very well, but let me see if I have a graph that can show us a nice visualization from that confusion matrix. Or better still, we can use a classification report also too. So I just copy this code from here and make use of it here too. Even though it's there. So just so we can get the accuracy score. So we can have a nice accuracy score. So which is our predictions and our tests. Oh, I even use the same spelling. So I think this because of the convention. So we have an accuracy of 77%. So that is the accuracy of our model, which is 77%. So with this model now, we now use it to predict. If we are okay with this model accuracy, then we can now use to predict our test data. And if we are not, then we need to build other models that is under our algorithms. So this is how you can see how we can build models. So this is how we can actually build models this is what we basically do as a data scientist. So we build our model. So once we build our model, then you want to check the accuracy of the model. So once you are okay with the model and you discover with the stakeholder that, okay, this is the model you actually have. And once everyone is okay with the model, then you can now continue to use that model to use on your test data. So we are going to be stopping in this place in today's class. Um, in our paid class, we'll show you how you can use this model to predict on your test data and have results. Just similarly what we just learned in this particular case, just a little step ahead of what you've actually done. So we've actually come to the end of today's class. I don't know if anyone have any kind of question about what we've learned in our today's class. And once you join our paid class, you have access to learn all of these algorithm, how you can make use of this algorithm. So we learn how to do all of those things in our paid class. I hope you all enjoy the class and it's time for us to ask questions. So let us ask questions. If you have any form of question, because we've come to the end of the 2 days bootcamp in our today's class. So don't let us forget to mark our attendance also too. Don't let us forget to mark our attendance. So let's ask question. So you can see how we can apply machine learning in an hospital. So this is one of the ways we can actually apply machine learning in hospital. So there's no any particular sector machine learning can never be applied. So it's time for us to ask questions. Please let's ask questions. Okay, the video recording is going to be available and sent to those that didn't make it early to the class. So we'll make sure that it's ready for our groups. Please, let's ask question. Do we have any form of question? I hope we're able to understand what I walk us through in today's class first. I don't know why this, once I go to chat, I don't know why it's leaving that at my screen. Okay. Yes, please, let's ask question.
Yes. Sorry, I have
Probably we don't
the
understand a
instead of
particular.
writing in the chat. Can you hear me, please?
Yes, I can hear you.
Yeah, so I didn't get the level of prediction for this model, how accurate it was.
Okay. We okay, let me scroll. So let me repeat that, but let me cancel this. I don't know why share screen. Just a minute, let me think it's up now. So these are accuracy. We have an accuracy of 0.77%. Do we get that now? I don't know
Yes.
why.
So we might maybe then we'll try it against other models to see if
Sure,
which one we
sure.
choose. Yeah, okay.
See if we are going to have a better accuracy, right?
Oh yeah. Okay.
Yes. So we just need to build other modeling aspect like your random forest, decision trees. So these are things that you can learn from SQL also too. But this is just like a walkthrough of how we can build models. So in our paid class, we do proper. So in our paid class, we do proper tuning some certain issues. Because you'll be working with more complex data set. This is more or less like a simple and a straightforward data set like that. So that is one thing we basically face. But the goal is just to let us know how we can actually build a model and how we can actually identify various problems we solve being a data scientist. Yes, so do we have anyone with questions, please? You have questions. Do you have anyone with questions? So further communication can also go on our WhatsApp platform. For those that were not able to meet up to this class, I guess probably the network or busy schedules not allowing that. So we have it. The WhatsApp platform is going to be open for us to further have means of what communication also too. So I want to say thank you so much for joining today's class. For those that joined the bootcamp, I want to say thank you so much for joining the bootcamp also too. So in case you have any question, you can use the WhatsApp channel that is being provided, and our answer to the question is going to be
Just one question. Sorry.
yes.
I noticed for the logistic regression, you copied a model already and pasted it here.
Okay.
I don't know, or was I right or wrong? I don't know.
No, no, that's not wrong. That's very right. So if I'm to build other model also, so I'll just go to the documentation. So we have a documentations. So how you can actually build those models. So that site that I want to copy from is like a documentation. So how you can actually build a model. So that's what I basically do. So I can actually type that offhand, but just to save much of our time, so I just went back to this documentation and to expose us to how can use that form of documentation also. So they are pretty straightforward. If I want to build other models, I'll just type the name of the models and go to sklearn, where's where the documentation is being found. So you go there, just copy the particular model you need and you run your code. It's pretty straightforward. It's not against anything. So you can actually copy the code from
Oh,
document.
okay.
It's,
Okay.
there's no against any, there's no any penalty for that. Okay, so thank you all once again for joining today's section. If you have any form of question or any other questions that you want to ask, the WhatsApp platform is actually available there. You can communicate with the team on the WhatsApp platform. Thank you all and see you someone at the end again.